So our first loop that I wanted to show you has to do with these special words of art. So you might have heard of for loops before. Well, this first one is a while loop. So basically, what I've done is I've defined the variable x as a integer of 99. And so what I can do with that is I can actually run a loop. And what a loop does is it can either run through a set of information, a list or a dictionary, or just any sort of information that you have. Maybe you're pulling in a file from somewhere else. And it can run through every item in that or a certain subset of the items within that container. And then whatever operation you want it to perform on it, it can do that operation within the loop. One of the tricky things with loops is you want to make sure that you're not coding it to be infinite, because then it'll just run forever. So then you have to basically cancel out the loop, which in your Jupyter notebooks is a little bit easier. Or if you're in an IDE, which if it means if you downloaded Python native to your computer, you might have to put in some sort of break command, or if you're in a command prompt, or if you are maybe the escape button will work depending on what IDE you're using. But as long as you are kind of using some sort of counter or some sort of variable that's kind of controlling this, typically you won't have that problem. But when you are debugging, if you're running into issues with your loops later on, be conscious of something known as an infinite loop. So if I put this as x equals to 99, and then I said while x is greater than 0, but I didn't put in some sort of manipulation that would change x so that it would go towards 0 and trend towards 0, this would just run forever. And then you would end up with millions upon millions of print statements. And I'm sure because this is in a cloud system, it'll probably run out of RAM and shut down pretty quickly. But if this is on your actual computer, it would just run and run and run and run and run. And then you have this endless stream of text and you freak out and then you have to close it out. We don't want that, because that wastes data, wastes time, wastes energy, and it's frustrating. But it will happen to you at some point. So I figured I would just let you know at the time that that's something that we all go through. So if you struggle with that or you run into that, don't panic. Just close it out, cancel it out, and then figure out where that infinite loop or issue or bug is coming from. So this loop that I'm sharing with you, again, the while command is basically saying while this condition is true. So remember we did Booleans a few weeks ago. So basically you're defining something as true or false. So in the case of x being 99, x being greater than 0 is true. It's not false. So this while power basically says that, okay, while the statement is true, it's going to do whatever I say below it. So when you do these things, you have to indent them inside of the while statement and make sure you have your colon here. That basically triggers it. You indent and then you have it do whatever you want it to do. So in this case, what I want it to do is I want it to basically print out a print statement of a string of text that basically takes whatever the value of x is and displays it and says it's bottles of pop on the wall. So the bus song, if you're growing up, the 99 bottles of whatever on the wall, 99 bottles of whatever, take one down, pass it around, x minus 1 bottles of whatever that thing on the wall. That's what I want this to do. So I actually have with the side of the loop 3 things that I wanted to do. The first thing is I want a print statement that is taking the variable, the integer, converting it to a string, and then concatenating it with another string of bottles of pop in the wall. Remember to keep spaces. You need to add that space at the end when you concatenate with something else, and then a space on the other side so it's not all bunched together. Then what I wanted to do is I wanted to take the value of x and then manipulate it so that it's now 1 less than it was before. So you might be using in a loop a count statement. So you might say, okay, while count is less than 55 and count is 0, and then after every statement you have 1 added to it, or 2, or whatever number you want it to be. until it reaches that limit. And then once it reaches that limit, then it'll say, okay, well, x is greater than 0 is false. And it will stop printing that and it will move on to the next statement you have in your program. So if we had something below this loop, it would do the next thing in the loop after we've completed the loop. So what it's going to do is it's going to take x. If it's at 99 right now, it's going to subtract 1 from that, and then it's going to result in x being 98. So then what happens is if I print again and say take when I'm passed around, it's going to, not instead of being displaying 99, it's going to be displaying 98. So even though it says x equals 99 above the while statement, when it loops back to the top, it loops back to the statement of the while. So anything above it won't be affected. So it won't go back to 99 and just go on forever. What it will do is it will start at 98. It will print out 98. It will subtract 98 to 97, and then it will print this with 97, so on and so forth, and so on and so forth until we reach 0. So if I run this, that's exactly what we get. So it did it very quickly. I could have put in some sort of time delay so it would do it every second or something like that, but I just had it print all at once. So what it did was it started with 99 bottle to pop on the wall, 99 bottle to pop, take one down, pass around 98 bottle to pop on the wall. And then it did 98, then to 97, 97 to 96, 96 to 95, and it went all the way down until we get we're in the 20s, then the teens, down to 1, and then we're back down to 0, and now it stops the loop. We can even print a statement after the loop to show you that the program will continue afterwards. It says, get me off this bus because you're sick of hearing this song over and over and over again. So let's print that out again. And then we see at the bottom, we get me off this bus. A different way in which we can approach, I'm just going back to the direct message. So yes, when the program begins, whatever the defined value of the variable is, will be that until the program begins. Then until the loop ends, it will manipulate x to whatever x becomes. So if you go afterwards and you wanted to print x, it's going to say x is 0. It's not going to go back to 99. It's just saying this is the starting value. And then while it's at this value, it's going to keep going through this loop. The loop is manipulating x every time to be a new value. So when we get past get me off this bus and we print x again, it's not going to be 99, it should be 0. So if we go down here, we see that it's 0. So if you wanted it to be something else higher, or you wanted to be 99 again, you would have to remanipulate the variable to be 99 lower in the program. So the second type of a loop you can do is a for loop. So basically a for loop is taking information from a list, a dictionary, some other data container, a data frame, whatever it might be. And it's running through all of the values within that container. So here we have a list. So this is not a 1, it's an L. So I apologize. It looks in the Courier font or whatever font you want to call this. It looks like a 1, but it's an L. So LST, which is your list, consists of 6 words. So willow, tree, maple, sunny, Bill, Wally. And then we have an empty list below it called mid_L, so middle L. And so what this for loop is going to do is you can really name whatever this thing is. It's for blank and blank. So this thing has to be whatever you're pulling your information from. This you can kind of just label whatever. The only thing that you have to be consistent with is that if this is X and you're trying to pull information from X, aka the actual like string itself or the integer, you have to make sure that the labeling is consistent between what's after your for loop with what you're describing as in your index, and then what you're pulling from if you're taking that and moving it somewhere else. So in this loop, what we're doing is we're taking words from the list, and if the third element within that string has the letter lowercase l in it, we're appending that word to a new list, which is this empty list of middle L. So we're basically saying if the middle letter in the word is L, we're going to add that to our new list. So what it's doing is it's going to take the first word here, which is willow. It's going to look to the third element within willow. So remember, we start at 0 in the indexing, so it would be 0, 1, 2. So your third element is L. So since that matches up with this L, what we should expect is because I'm requiring it to append, remember, if you want to append something to a new list or another list, you take the name of the list, dot append, and then whatever value you're trying to put in there. So what this is doing is I've combined a for loop and a conditional statement and said, okay, well, while we're looking at the things within this list, so for every item in this list, if the third element of that item is the letter L, I want you to append the letter or the word, not the letter, but the word to this list here. So what ends up happening when I run this is if we actually look through this list, we see that the third element of willow is L, the third element of tree is not, so we should expect that to not be in our new list of middle L. The third element of maple is not L, so we shouldn't expect that in there. The third element of sunny is not L, so we shouldn't expect that in there. Third element of bill is, and the third element of Wally is, so we should expect willow, Bill, and Wally to be in this list. And that's what we get. Now, what if we change this to being the fourth element of L, or being L? So in willow, we see that that would be true. We see that this would be true. We see that this would be true. We see that this would be true. So we should actually expect maple to be added to this list in addition to willow, Bill, Wally. And we see that. So basically a for loop is going to take information that is from some sort of container, could be a dictionary, list, data frame, whatever you call and require, it's going to do that operation. So it's going to read through everything in here in this loop. And then we chose a conditional statement. So again, remember an if statement, remember indexing, this is going to pull from the third element of this item. If we were looking at list 3, it would actually be pulling the third item from the list as opposed to the third character in the item. So based on how, like, kind of what frame of mind you're looking at. So if this was a list and we were just pulling list.3 or list 3, it would be pulling this, the word sunny. But if we're taking X, which is one item within the list, and looking at the index of X3, that's actually going to be the fourth character within the string, assuming that there are 4 characters in the string. You might run into problems in a list like this if you had a word such as, like, if you're doing X3 and you get a word that's only 2 characters or 3 characters long, you would actually get an error because when it's reading through the list, it would be like, okay, that index doesn't exist. So later on, what you could do is you could do kind of sort of a try except thing if you want this to override past that potential error, where you would say, okay, like, do it. If it doesn't work, just skip to the next element. So we'll deal with that later on in another class. But for now, just know that basically loops can be used for basically taking information, manipulating data, adding it to new containers, stuff like that. So a while is basically giving it a condition to satisfy and making sure that condition is finite. So that way it's not an infinite loop, and then it performs the operation. If you're doing a for loop, then it's pulling information, so it should run out of information at a certain point. But you also have to be careful because you can manipulate multiple things in here. You could be doing this appending to a list, doing a math operation, and you have to make sure that those math operations aren't running through the entire list over and over again. If you end up doing like computer science or anything like that, you might learn about O notation that basically explains kind of like efficiency in terms of running your code. So basically, if you're just running through the list one time, it's O, but if you have to run through the list and then in this within the loop, there's a loop within the loop that basically is running through that data again, then it's O squared. So you don't want to basically be overusing your power if you have a finite computer or you have a huge set of data. Like on these things, it's not using very much information. So even if you have an infinite loop, it's okay. But if you're like using like gigabytes worth of data to do some sort of major data science project, probably not the best way to go. So here's another example of a for loop using a dictionary as opposed to a list. Basically, we have an example here where we have electoral votes. So basically, with the presidential election coming up, each state has a certain set of electoral votes that is equivalent to the number of senators, which would be 2, plus the number of House of Representatives they have, which would be 1 if it's the smaller states, 2 maybe up to like 50 something in California. With the exception of DC. DC actually gets 3 electoral votes. They don't have any congressional representation, but they do get to elect the president, whereas like our territories like Puerto Rico and Mariana Islands and Guam, they don't have electoral votes. So this is just a small dictionary that's kind of a sample for what your assignment will be for next week, which is a dictionary of all of the states, all of their electoral votes, and then there'll be a loop that accompanies it to do some sort of operation. So basically, here's a small sample of, I don't know, 4 or 5 states, 4 states plus DC. We see that Wyoming has 3 electoral votes. We see DC has 3 electoral votes. We see Vermont has 3 electoral votes. We see Ohio with 17. We see Michigan has 15. So what this dictionary does is like last week, basically you have a key and then you have a value attached to the key. So when we do a for loop of the dictionary, what it's going to do is it's going to take a look at the value within each item within the dictionary. So you might think, okay, well, isn't there a problem here? Because if I do X electoral votes, is it pulling from the key or is it pulling from the value? Well, what's fascinating and kind of nice about a dictionary is what it's doing is it's basically reading in the keys, but when you index the actual when you index the actual item within the key, it actually is going to associate with its value. So what that's telling you is that what it's going to do is while it's reading through each item within the dictionary, what it's going to do is it's going to read the key of Wyoming. When you index it and do a conditional statement, it's going to compare not the key, but it's going to compare the value of that item within the dictionary to your conditional statement. So in this case, we want to find all of the electoral, we want all the states within this dictionary that are 3 electoral votes. So that's what this conditional statement is requesting. It's saying, okay, if the electoral vote value of that key is 3, then I want you to print that state out. So when we do that, we end up getting Wyoming, which has 3, DC, which has 3, Vermont, which has 3. We don't have Ohio or Michigan equal to 3. So if we change this to 15, it should only print Michigan. If we change it to 17, it should only print Ohio. If we switch it to 5, then it shouldn't print anything, and it doesn't. So basically, loops are a way of creating new variables from a piece of data to do multiple operations efficiently. So instead of having to basically hit enter 100 times or run the program 100 times, you can have it iterate through all of the information, all of the data, etc., in an efficient manner.